All right, here we go. This is the last part of the unit here. And for some of you, there might be light at the end of the tunnel because after this unit, we have one more unit of proofs, and it's not until like April, May we do them. So, okay, we're not going to be doing proofs for a while, a couple units anyway. So maybe there might be light at the end of the tunnel for a couple of you here. But on the other side, a lot of algebra coming up in the next couple units. A lot of algebra. All right, I want to just go way back here, way back. And we did a huge unit on congruent triangles. And we graphed them. And I said, all right, back in middle school, you used to do these things called transformations. Slide them, turn them, whatever you did with them. And there was 3 of them we listed that made triangles congruent. It would not change the size or the shape of the triangles. Do you remember those 3? There was a translation, yep, and you don't need to write any of this down. It's not anywhere in your packet yet. Translation, which I slide it. What else made it congruent? Rotations, yep, when I turned them, that doesn't change the size. And then finally there was a reflection when I flip it. And then I said to you guys, hey, aren't we missing one that you talked about? Dilation. Why didn't we write dilation up there? It changes the size. But now what unit are we in? Similarity. So if you dilate a figure, do you think the 2 are still similar? Yes. And that's what we're going to focus on today are the dilations now. Forget these. We're not doing congruent anymore. We're doing similar triangles, so we're going to focus on a dilation. And what's a dilation? It enlarges. Does it always have to enlarge? No. What could it also could enlarges or reduces a figure? Here's the key, though. It does that proportionally. Meaning, what about their sides? They should be in the same ratio today. When I dilate a figure, the sides are in the same ratio. Okay. Center of dilation. I wouldn't be too concerned. You know what? Just cross it out. How about that? We're not concerned about those. Just where I dilate around. Scale factor. Oh, yeah. You're going to be concerned about that. I've been using a different term this unit, similarity ratio. But be familiar with both because you're going to probably see scale factor on tonight's homework, similarity ratio. That's my ratio of, how do I find that? I pick 2 what? I got 2 triangles that are similar. I pick 2, just any 2 sides? Corresponding sides. There you go. It's the ratio of 2 corresponding sides. All right, let's talk about this enlargement versus reduction. All right. Enlargement, you guys know, gets bigger, right? Gets bigger. Okay. What's that got to mean for my scale factor then? Because it's going to be a number. What do you think you're going to know about that number? To say, oh, because it's this, it must be an enlargement. What do you think about that number that I'm going to give you as a scale factor? Well, it's only going to be one number. It's going to be above 1, greater than 1. All right, so if you are enlarging a figure, making it bigger, that scale factor, that ratio will be bigger than 1. So what if you think you're reducing it? I'm not a big fan of less than 1. Because when you go less than 1, you're going into the negative territory, which we're not going to discuss. It's going to be between 0 and 1. When you do a reduction. And I always get the question, well, what if it's equal to 1? It's the same figure. Okay, the ratio is it's in a ratio of 1 to 1. It's the same figure. All right. All right, so I'm going to turn this over to you guys now. I got 2 diagrams there on the next page. We're going from A to figure B. First, tell me if it's an enlargement or a reduction first. A to B, enlargement or reduction. You get the easy one first. Here we go, 16, enlargement or reduction? Yep, that was an easy one, huh? Now I want you to find the scale factor, though. Wait, he said it was an enlargement. What should you know about the scale factor when we write it? It should be bigger than 1. How do I find it? It's the ratio of 2 corresponding sides. Can you find 2 corresponding sides in this diagram that you can count so I don't have to bust out distance formula? Can you find 2 sides that you can count? All right, how long is this bottom side here? This one right here on A. I'm on A, sorry. 1, 2, 3, 4. And it matches up with the corresponding side length of number, we don't have 30? How about 19? 5. You've already answered this, but I'm going to ask it again. Do I write 4 over 5 or 5 over 4? One's right, one's wrong. Why is the scale factor, I'm going to abbreviate it SF, so I don't have to write it all out. Why is it 5 over 4 versus 4 over 5? It says that it's an enlargement, so this number better be bigger than 1. Okay? Yes, it is incorrect if you write 4 over 5. All right, next up. A to B, enlargement or reduction? 6, what do you got for me? Got it. It is a reduction. So your scale factor should be between 0 and 1. So pick 2 corresponding sides, see if you can count them. Three, what do you got for me? 1 over 3. Why don't we go 3 over 1? That would have been bigger than 1, right? So that's how I know where to put it. We okay? Reduction, enlargement, and how to find the scale factor. Are we okay? Yes, Thomas.
Would it be okay if you wrote SF equals 2/6 and then you said equals 1/3?
You can leave it 2/6. That's fine. You don't need to do 1/3 for me.
Oh, okay.
Just as long as you don't do 6 over 2.
Oh, okay.
Yep, 2/6. I don't need it reduced. All right. Anything else? Okay, last thing. Anytime we can go on a graph, we're going on a graph. So I got 2 triangles that one I dilated. I'll let you guys graph it. And then we got to prove that these 2 are similar to each other. So I'll give you a minute or 2 to graph it, and then we'll talk how am I going to prove them similar. All right, showing they're similar. You have 3 ways this unit we've talked about. 3 ways to show triangles similar. Quick review, what are they? Should be angle, angle I have. Well, let's start with that one. Is that going to be a possibility if I graphed them? No. There's no way on a graph you're going to tell me that angles are equal unless they're right angles. Another method, side angle, side, similarity. What's my problem still? That darn angle. I can show you the sides are these two sides are in proportion, but I don't have an angle proving congruent. So what's the final method we have? Okay, which means all three pairs of sides are in the same ratio. How can I show that? Find the distance of all of them. All right, and I am not going to have you do all 6. All right, I'm going to divide it up into groups here. 1, 2, 3, 4, 5, 6, 7. Okay, we got 8 groups. All right, so triangle ABC. All right, I'll assign side AB. We'll go these 2 front groups right here. You guys got distance of AB, simplest radical form, please. Check it with each other when you're done. BC. We'll go that group right there, BC. And then CA, group in the corner over there, CA. And then we'll do triangle DEF. Again, simplest radical form if possible. DE, we'll go that group in the back with DE. All right, DE. DF, we'll go those 2 groups right there. We'll combine up DF, and then you gentlemen over here have EF for your distance. Or Pythag, it's up to you. All right, check with each other, make sure it's in simplest radical form if it needs to be, and then we'll come back and talk and see if their sides are actually in the same ratio. All right, let's just make sure if you didn't have it, if it wasn't your responsibility, make sure we get it down. AB group, what do you got for me? 2 radical 2. BC group, what's up? Square root of 10. CA group, also square root of 10, huh? Little bonus right now. What type of triangle is ABC? All right. DE group, what do you got for me? Yes. DF group, 2, what do we have? 2 radical 10. And how about the EF group? All right. I have no idea. Just looking at this, I have no idea if their corresponding sides are in the same ratio to do side, side, side. So I need your help now. And the next step is matching up all the sides. So AB, 2 radical 2 matches up with what? 4 radical 2. Oh, hold on. I should have figured. Which one are we going from? A to D. So we're enlarging it, right? Everyone agree we're enlarging this? Okay, so I should be taking the bigger sides first. So 4 radical 2 over 2 radical 2. All right. What does DF correspond with? DF corresponds with AC, which is radical 10. Oh, here we go again. And EF. We're good. This tells me nothing right here. Okay. Can you help me reduce to see if they're in the same ratio? What's that going to reduce down to? 2 over 1. Ooh, how about this one? The radical 10s can cross out. Yep. So 2 over 1. How are we going to try to prove these triangles similar? By what method? Side, side. There's a third S there. Just because we won here doesn't mean we're good to go. The other pair could be in a different ratio and then we're done. They're not similar. But also, radical 10s cross out and it's 2 over 1. All right. So are these triangles similar? So we'll say triangle ABC is similar to triangle, what's it, just DEF if I tried to match them up? DEF, give me a reason. By side, side, side. Hey, that's how to prove triangles congruent. Got to have the tilde there. Got to on Friday. Questions there? All right, before I let you start your homework, which you're going to right now, look at the bottom of your page. Everyone see on number 6 tonight, I gave you, it says in parentheses, use the diagonals for the scale factor. That's because the figure I have given you, remember here, you guys could easily just count. On the figure on number 6, you can't count them. You can't count the sides, so instead use the diagonals to find the scale factor. You'll be able to count a diagonal. All right, get started. Here we go. Either with the bookwork or with your 2 review problems, rounded to the nearest hundredth.